This is a walkthrough of the past paper from summer 2022, paper 1H. So the higher paper 1, questions 1 to 11. So key information, we read, answer all the questions, writing answers in the spaces provided, and making sure that we write down all the stages in our working. So we've been asked to solve this linear inequality, which means we need to come up with an inequality statement. So adding 27 to both sides, we get 7x is less than 35. And divide by 7, we get x is less than 5. 124 as a product of prime factors. So we need to do a prime factor tree. Let's just do some simple division. So dividing by 2 first of all, that's a prime number, so we circle it. Then that would be 62. Divide by 2 again, gives us 31, which is a prime number. So this would be 2 squared times 31. A delivery company has a total of 160 cars and vans. The number of cars to the number of vans is 3 to 7. So I'm just going to write on the side here, cars to vans, 3 to 7. Okay, just read a bit more of the question before I do this. Each car and each van uses electricity or diesel or petrol. So we've got 3 options. An eighth of the cars use electricity, 25% of the cars use diesel, and the rest of the cars use petrol. Work out the number of cars that use petrol. So we want to calculate the number of cars that use petrol. So first of all, we need to work out how many cars there are. Okay, because we want the number of cars. So 3 plus 7 equals 10. So that means 3 tenths and 7 tenths. So 3 tenths of the cars are, 3 tenths of the vehicles are cars. So 3 tenths of 160, that's 48. So 48 cars. Now, an eighth of 48 is 6. So 6 of the cars use electricity. So we could put a little table together here. Electricity, diesel, petrol, total. We've got 6 of them using electricity. 25% of them use diesel. So 25% of 48. That's the same as a quarter of 48, which equals 12 cars. That's using diesel. Now there are 48 in total. So 18 plus x equals 48. X equals 48 minus 18, which is 30. 30 cars use petrol. And key, we had to show all of our working for this. So this was the idea of putting the table together as well and using some algebra. So 1.63 times 10 to the minus 3 as an ordinary number. So we're using some standard form here. So this is written in standard form. We want to write this as an ordinary number. So 1.63, that's been divided by 10 3 times. So the 1 has moved 3 spaces to the right. 1, 2, 3. So from here, 1, 2, 3. So 1, 6, 3. 0.00163. 438,000 in standard form. So we start off as 4.38. And we've got to get to 438,000. So this 4 has got to be multiplied by 10. 1, 2, 3, 4, 5 times. Right, so we've got a calculation in standard form. So first of all, we do the 4 times the 6. 24. 10 cubed times 10 to the minus 5 equals 10 to the minus 2. So we wind up with 24 times 10 to the minus 2. Now this is not in standard form, so I'm going to write 24 in standard form. So that is 2.4 times 10 to the power 1 times 10 to the minus 2. Now we can correct, so that becomes 2.4 times 10 to the power 1 minus 2 is minus 1, so minus 1. 2.4 times 10 to the minus 1. A regular hexagon and a regular pentagon. Work out the size of the angle marked X. Okay, so if I work out the interior angles of both the hexagon and the pentagon, and I add those together, take those away from 360, then I'm going to get X. So that's my strategy. So to work out the interior angle of a regular hexagon, regular meaning that all of the angles are the same, I've got n, the formula I'm going to use is n minus 2 times 180. So that's going to be the sum of all of the interior angles in the shape, and I'm going to divide by n to get the actual single one. So for a hexagon, that would be 6 minus 2, which would be 4. 4 times 180 degrees, then divided by 6 equals, well, 180 divided by 6 is, 6's go into 18 3 times, so that will be 30 degrees. So 4 times 30 gives me 120 degrees. So for the hexagon, it's 120 degrees, and I'll note that on my diagram as well. So for the pentagon, that's 5 minus 2, which will be 3. So 3 times 180 degrees divided by 5. That's the pentagon. That's the hexagon. 180 divided by 5, that's the same as 360 divided by 10. So that's 36 degrees. And 3 times 36 is 90 plus 18, which is 108. 120 plus 108 equals 228 degrees. I'm going to take that away from 360. It's 2. 5 minus 2 is 3. 132 degrees. Right, so completing a table of values for a quadratic here, then plotting it, and then doing a calculation from it. So let's have a look. So we've got our x value, x squared, and then minus 3 times it. So if we really want to kind of set this out and have some bit of working, minus 1 squared is 1. Minus 3 times minus 1 is plus 3, and then plus 1. So 3 plus 1 is 5. So that's 5. Then 2 squared is 4. Minus 3 times 2 is minus 6, plus 1. Minus 6 plus 4 is minus 2, plus 1 is minus 1. So I can see the symmetry here, 5, 1, minus 1, minus 1. So this should be 1. Let's just test it. 3 squared is 9. Minus 3 times 3 is minus 9. 9 minus 9 plus 1, which is plus 1. Good. Plus 1. And I'm not going to bother doing the calculation for this one, so because it should be symmetrical, so this should be 5 as well. Right, so minus 1 comma 5 is going to be plotted over here. 0 comma 1 goes through here. 1 comma minus 1, then 2 comma minus 1. So we already know it's not going to be totally flat here. It's going to go below this. 2 comma minus 1. 3 comma 1. And 4 comma 5. So 4 comma 5 is up here. Now we just join these with a smooth curve. It's not too bad. Now using the graph, find estimates for the solutions of the equation. So my solutions, just make sure this is the same equation here. X squared minus 3x plus 1, x squared minus 3x plus 1 equals 0. So we're looking for the solutions here, where it cuts the x-axis. And I'm going to go for 0.45 and it probably looks like it should go through 0.5 and 2.5. I'm going to go for. Okay, so we've got two cubes here, A and B. Cube A has a mass of 81 grams, cube B has a mass of 128 grams, so I'm just going to get the key information. I want to get density, so I know I'm going to have to work out the volume. So first of all, I'm going to work out the volume for each cube. So that's 3 times 3 times 3, so that is 27. And the volume here is 4 cubed, which is 64. Then I'm going to draw a table. So for A and B, mass, volume, density, just reminding myself, density equals mass divided by volume. So the mass of cube A is 81, the volume is 27, and so the density is mass divided by volume, so 81 over 27, which equals 3 grams per centimetre cubed. And for B, the mass is 128 and the volume is 64. So the density is 128 divided by 64, which equals 2 grams per centimetre cubed. Now we want to work out the density of cube A to the density of cube B, giving my answer in the form A to B, where A and B are integers. So it's very important we don't use these fractions, we use the integer values. So density of A to density of B, so A to B is 3 to 2. Question 8. So the amount of snow in centimetres that fell each day for 30 days. We want to, so we've got here between 0 and 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. So they're even class widths. We've got the frequency. We want to get an estimate for the mean. So snow per day. Okay, so we've got to then put a separate column here. So midpoint. And then that'll be x. And then fx. So 2 extra columns. Right, so the midpoint is 5, 15, 25, 35, and 45. Frequency times midpoint. I might just create a bit of space here. I'll just erase this line. Give myself a bit of space for calculations. Right, so frequency times the midpoint, so 5 times 8. What, 8 times 5 is 40. 10 times 15 is 150. 7 times 25 equals 4 25s are 100, so that was 175. 2 times 35 is 70. And 3 times 45 would be 135. So 3 times 45, 135. So the sum of fx, so that'd be 5, 10, 10, 7, 8, 9, 10, so 14, 24, 5, 6, 27, 1, 2, 3, 4, 5, 570. And that's divided by 30. So 570. So the mean is approximately equal to 570 divided by 30. That's the total frequency. So 57 divided by 3, which is approximately equal to 19. That is centimetres. 19 centimetres. The cube is placed on top of a cuboid as shown in the diagram to form a solid. The cube has edges of length 4 centimetres. So the cuboid is 7 by 6 by 5. Work out the total surface area. So surface area. So if we draw the net of the cuboid, so then I'm going to have sides of 6 and 5 alternating. So at the front it's 5, so this is 5, and 6, then 5, then 6, that's 7, and right, so we've got a 7 by 5 at the front, that's 35 centimetres squared, and a 7 by 5 at the back. We've got a 7 by 6 on top, and a 7 by 6 on the bottom. And then a 6 by 5 on the side, and another 6 by 5 on the other side. So the total is 30 plus 42 plus 35, then times 2. 30 plus 42 plus 35, 7, 6, 10, so 107. 107 times 2, 14, 214 centimeters squared. So that's for the cuboid. The cube, the surface area of the cube is 4 by 4 and then times 6. (16) times 6, 36. 6 times 1 is 6, plus 3 is 96 centimeters squared. Now then, not all of that is on show though. We have this surface here, so a 4 by 4, which is covering up, which is obscured for the top cube, but it's also being obscured for the bottom cuboid. So we want double that taken away. So you've got 214 plus 96. 6 and 4 is 10, 9, 10, 11, 310. But we want to take away 32. So 310 minus 32. 8. So 30 minus 3 is 27. So 278 centimeters squared. So the profits made each day at the cricket club in 100 days. So 0 to 50, 50 to 100, 100. So these are evenly spaced. We've got the frequencies. We want a cumulative frequency table. Right. So that's just adding the preceding amounts. So between 0 and 50, then 0 to 100 is going to then be the 10 plus the 15, so we 25. Then 50. Then 80, 85, and then 100. And then we're going to plot this information. So we're plotting at the end of the class interval. So 50, 10. 100, 25. 25, so 2, 4, 5. 150, 50. That's 50 there. 200, 80. 200, 80. Then 250, 85. 80, 2, 4, 5. And then 300, 100. And now we need to draw the graph. So starting at 0. Right, okay, so that's my cumulative frequency graph. And we need to use the graph to find an estimate for the number of days on which the profit was less than £125. So this means at £125, I've got to draw a straight line. 125, a straight line, 125. And then across from 125. Here we go. So 37. And then use the graph to find an estimate for the interquartile range. So we want the value at the quartile, so it obviously goes to 100, so the lower quartile is at 25. Oh, well, we had that already. We had that cumulative frequency of 25, and that was at 100. So we know that's exactly at 100. So that's at 25, 2, 4, 5. Right, so that's Q1. And then 3/4 of the way through. So that's 60, that's 70, 2, 4, 5. Right, so that is 150, 175, 180, 185, 190, 192 maybe. £92. Right, Cormac has some sweets in a bag. The sweets are lime flavoured, strawberry flavoured, or orange flavoured. In the bag, the number of lime to strawberry to orange. So lime to strawberry to orange. It's 9 to 4 to X. Right. Cormac is going to take at random a sweet from the bag. So the total is 9 plus 4 plus X. The probability he takes a lime flavoured sweet is 3/7. So lime flavoured sweets is 3/7. Work out the value of X. Okay. Right, well, if we've got our total, it's 9 plus 4 plus X, and then lime is going to be 9. So taking a lime sweet is going to be 9 out of 9 plus 4 plus X. So that probability equals 3/7. So obviously this could be multiples of 3/7. So we might need to go to the next one up. We might need to go to 6/14 or 9. In this case, it looks like best bet is to go to 9/21, because obviously we've got 9 here. So we're going to multiply both numerator and denominator by 3. So that gives me 9 out of 9 plus 4 plus X equals 9/21. So the denominators are now the same. So if the denominators are the same, we can then assume that the numerators are the same. So the denominators should be the same as well to give an equivalent fraction. So therefore, 9 plus 4 plus X equals 21. That means X equals 21 minus 13, which equals 8. And X equals 8. Right, good. So pleased with the work so far, and we got about an hour to complete the rest of the paper in, and we're about halfway.